Hello, Heritage Academy Geometry students, and welcome to another exciting edition of Geometry, Seeing, Doing, Understanding. This is lesson 5.3, Triangle, Side, and Angle Inequalities, and lesson 5.4, the Triangle Inequality Theorem. Now, I know that we have done a lot of work lately with theorems and proofs, and it's been a little stressful and maybe even exhausting. So just remember that every time geometry makes you feel like you want to cry, you have made Grumpy Cat very happy. Before we go any further, let's talk about those ultimate and intermediate objectives. Remember that throughout chapter 5, we've been talking about how Jesus really called us to be servants, to serve. And when we serve others, we are setting ourselves below others. And it gives us that idea of inequality. So I want you to continue to think about that and how you might serve someone today or in the near future. Let's talk about intermediate objectives that are specific to lesson 5.3 and 5.4. So we're going to explore how unequal sides in triangles create unequal angles. We're going to determine if the measures of triangle sides given can actually make a triangle. Sounds interesting. And we're going to learn 3 theorems. Yep, that's right. Theorem 13, which is all about unequal sides. Theorem 14, which is about unequal angles, and it just happens to be the converse to Theorem 13. And I know I've got you on the edge of your seat with that one. And Theorem 15, the Triangle Inequality Theorem. Lesson 5.3 opens with this image. And this is a painting that was done way back in the day. And what artists started to do is they got bored with the regular old painting and portraits that they were making, and somebody decided along the way, hey, I think that I'm gonna paint this in a whole different way, and they used perspective to do that. So actually with this painting, when you look at it from the front, this is what you see, but when you see it from the side, it looks totally normal, which is crazy. It's like, how did they do this back then with no technology? I don't know. Okay, so look at this picture now. In this image, you can see this little point in the middle. And from that point, several rays are extending, which make all these angles. So I want you to take this idea of perspective and angles and rays and how they all work together to make a little something called triangles as we study inequalities in triangles in more detail. So take a look at this triangle. You could call this triangle PQR or triangle RQP or, whatever, as long as you go in a certain order. But let's focus right now on the lengths of the sides that have been given. So QR has been given a length of 8, PR has been given a length of 9, and QP has been given a length of 10. For each side in a triangle, there is an angle that is opposite or on the other side of the triangle. So notice that the angle that is opposite of side QR is angle P. The angle that is opposite for PR is Q. I'll bet you can guess the opposite angle for QP. That's right, it's R. Now, here comes the theorem. If two sides of a triangle are unequal, the angles opposite them are unequal in the same order. What this really means is that if we're talking about our side that measures 8 and our side that measures 9, it means that because QR is a measure of 8, which is smaller than 9, then angle P is going to be smaller than angle Q. Now that wasn't so bad, was it? Before we go any further, you know that we got to prove this thing. So let's take a look at triangle ABC. And given that this triangle has BC being greater than AC, let's prove that angle A is actually greater than angle B. I know you can see it visually. I know you can probably explain why based on that theorem, but let's give the proof. So get a piece of paper out and maybe hit pause every once in a while and challenge yourself to write this proof out as we go along. Now, before we go any further, let's add a few things. I want to add this line right here, and I'm going to put a point with it. And the point that I've chosen there, I can put that there because the ruler postulate says that I can put points on a line. So that's all we're doing here. But the point is in a special place because it actually creates a triangle where we have some equal sides and equal lengths, and we're going to get to that in just a minute. Let's label this point D. And let's not forget that we have this larger angle in our original triangle, and this angle we will call CAB. But then we've made this smaller angle here, which also is the same size as this angle over here, and we're going to call those angle 1 and angle 2. Now, because of the placement of my point D, I put it in such a spot where this line CA is the same length as line CD. The reason then that I can say that those two angles, angle 1 and angle 2, are equal is because we have an isosceles triangle here. So let's start with our given information, and we're going to add all of the reasons in later. I just want to walk you first through the main concepts here, through the statements. So we know that angle 1 equals angle 2, but I want you to be thinking about why this is mathematically. We can also then say that CAB equals angle 1 plus that really small angle we made there, DAB. So also we can say that angle CAB is larger than angle 1, and you can see it visually, but there's a mathematical reason there as well. CAB then, if it's larger than angle 1, must be larger than angle 2. Angle 2 is greater than angle B, and there's a really good reason for that. And this is all going to bring us to this conclusion that angle CAB is greater than angle B, or in other words, that angle A is greater than angle B. So if you've been following along with me, you might want to hit pause every once in a while as we fill in the reasons. And I want you to start thinking on your own here about why these things are true. So, of course, triangle ABC having BC being greater than AC was our given information. But what about angle 1 equals angle 2? Well, this is because if two sides of a triangle are equal, the angles opposite them are equal. So be thinking isosceles triangle here. If angle CAB equals angle 1 plus DAB, we're talking here about the betweenness of rays theorem. An oldie but a goodie. And then we can say that angle CAB is greater than angle 1 because of a newer theorem that we learned, the whole greater than part theorem. And that one is really easy to see visually. Angle CAB is also then greater than angle 2 because we just substitute angle 2 in for angle 1. But what about angle 2 being greater than B? Well, this comes back to the idea of exterior angles. So see that that is actually an exterior angle to the triangle DAB. So when angle 2 is an exterior angle, in that case, angle B is a remote interior angle. And we know that exterior angles are always greater than either of the remote interior angles. So then we can finally say that angle CAB is greater than angle B because of the transitive property. Whew, that was a lot. Boy, I hope you feel smarter. Theorem 14 is simply a converse of Theorem 13, and it states if two angles of a triangle are unequal, the sides opposite them are unequal in the same order. So here in this triangle ABC, you can see our angle measures are given, and by those angle measures, you can tell which lengths are going to be shorter and longer. So we'll discuss those two theorems more in class, and this last theorem, the triangle inequality theorem, is another one that we're going to talk about more together. I just want to show you the basics of this theorem. This theorem states the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you look at side A, side B, and side C, and you start to think about how they relate to one another by adding them together, if we add A plus B, that length is going to have to be greater than C to make a triangle. If you added side A plus C, then that has to be greater than side B. And also, if you add B plus C, that needs to be greater than side A. We're going to continue to explore triangle inequalities in class, so I will see you next time in geometry.